Okay, problem number 16 says aqueous cadmium chloride, so this CdCl2, aqueous, reacts with sodium sulfide, Na2S, and that's aqueous, to produce bright yellow cadmium sulfide, CdS, and NaCl, right? So this is solid, and this is aqueous. Write the balanced equation for this reaction. So we go to 2 there, and we're good. So it says how many moles of CdCl2 are in 50 milliliters of 3.91. So we've got for every 3.91 moles of CdCl2, there is 1 liter, because remember that big M means that we've got moles per 1 liter of CdCl2 solution. And then we got 0.05 liters. So times 0.05 times 0.05 would be 15. That would be pretty close to 0.2. So it's 0.19, about 5, 6-ish moles of CdCl2. There's that many liters. So there's our final answer. And then the second question asks how many moles of CDS would be formed? Well, the ratio between this one and this one is 1 to 1. So it would be 0.1956 moles of CDS. And then the last question asks us how much of that mass of CDS is formed. So we've got for every 1 mole of CDS, there is about 145 grams of CDS. And then we ended up with 0.1956. That's about 0.2. We're going to say it's about 0.28 grams. Oops. 2 tenths, 28 grams of CDS. Okay, and then we got a chemist wants to react 12 grams of barium sulfate by taking 0.6 molar with excess H2SO4. So we've got, let me rewrite this equation, BaCl2 plus H2SO4 yields BaSO4 and 2HCl. And they want to know what's the volume, milliliters or liters. So this isn't too bad. This is, we're going to say barium sulfate. We started with 12 grams. And this is 1 mole of barium sulfate. And we'll say that that's 233 grams of BaSO4. Get from here to here, we divide by about 20. Looks like probably closer to 19 and a half, let's call it. And this says we want to know BaCl2. So, and it wants to know BaCl2. So how many milliliters of this? Yeah, that's what we had before. Okay, so we could say how many moles is this? Well, it's 1 mole here. And we know that divided by 19.5 is right around 0.05, let's call it 1 moles of BaCl2. And we know that it's, from this problem, this part of the problem, we know that there's 0.6 moles of BaCl2 in 1 liter of solution. And we don't want 0.6, we want 0.05, which is divided by about 12. And 1 divided by 12 is about 8 milliliters, 0.08 liters, which is about 80 milliliters. Okay, and the last question, we know that from this problem, that for every 25, let's call it kilograms, of nickel 2 sulfate, NiSO4, there is, or hexahydrate, 6H2O, there is 100 kilograms of NaSO4 and water, which is 6H2O. Remember, this hydrate just means that it's a solid, but it's just the water's in the solid. So for every, we want this to be 2.402 kilograms. There is blank kilograms of solution. And to go from here to here, we're going to say that that is, I'm going to use a calculator for this one. I know. A calculator. Okay. Divided by 10.4. And so I'm going to take this and divide that by 10.4. So that's going to come out. Or I could have just done times 4. That might have been a little bit easier. Times 4. That would be 9.608 kilograms. Now, that is of solution, which means that it's these two things, which means I have to subtract 9.608 minus 2.402, which means that it's basically 70%. So this is 7.206 kilograms of water. Hope that helps. I'll see you tomorrow.